Question number 51. The correct statement for lithium is, let's check the statements. It has lowest melting point among the all alkali metals. If I talk about alkali metals, lithium has the smallest size and it is very hard and it has high melting point also. It means this statement is wrong. Further, it is most reactive alkali metal. This statement is also incorrect because the most reactive alkali metal is cesium. After that, its compounds are predominantly covalent. Yes, the compounds of lithium are predominantly covalent. This is a correct statement. Further, it is softest alkali metal. No, it is the hardest one. That's why it's also wrong. So the correct option is only given in option 3. That's why the correct answer is this. Now, question number 52. The peroxide bond are present in. We have different compounds. We have to find out those compounds in which peroxide bond is present. So, suppose I talk about the first one. First is BaO2, barium peroxide. In case of peroxide, there is the peroxide linkage. What is that peroxide linkage? It is actually this type of linkage. In case of BaO2, this type of linkage is present. That's why I'll choose this compound. But let's check other compounds also. KO2, that is potassium superoxide. Peroxide linkage is not there. Then Na2O2 is also a peroxide in which peroxide linkage is there. That's why these two are the correct one. Further, PbO2, lead oxide. It does not have peroxide bond. So, the correct answer is given in option 3. That is A and C. And here is the correct answer. Option 3. Let's take next question. Question number 53. The correct order of thermal stability is, we have lithium fluoride, sodium fluoride and potassium fluoride in all of these options. It means we have to compare the thermal stability of these three compounds. This lithium fluoride, sodium fluoride and potassium fluoride. Thermal stability depends on the lattice enthalpy. More the strong lattice is, more the lattice enthalpy is required to break. More strong is the lattice, more lattice enthalpy is there, and thermal stability is more for that particular compound. So if I talk about this lithium fluoride, it has very high lattice energy due to its small size, as well as the size of fluorine is also small. So maximum lattice energy is there for lithium fluoride, then for sodium fluoride, and then potassium fluoride. And on that basis, this is also the correct order of decreasing thermal stability. And this order is given here in option 3. That's why I'll choose it as the correct option. First, potassium fluoride, the least one, then sodium fluoride, and highest thermal stability is there for lithium fluoride. So, option 3 is the correct one. After that, question number 54. White phosphorus, when heated with calcium hydroxide, produces. What you are going to do here? You're just going to heat this white phosphorus with calcium hydroxide. The solution is there, and during that there is a disproportionation reaction that's taking place, and during that disproportionation reaction there's the formation of so it would be the balanced chemical reaction. This is the reaction that's taking place. So which compound is formed here? The compound that's formed here is this. Where this is given? It is given here in option 1. That's why this option 1 is also correct. Further, question number 55. The incorrect statement for beryllium is, it forms electron deficient halide. Yes, it forms electron deficient halide because octet of the beryllium is not completed. Further, it does not show flame test. It is also true because it does not have unpaired electron. It forms most covalent compound among its group. If I talk about this beryllium, it also forms most covalent compound among its groups due to its small size. Further, it shows diagonal relationship with lithium. This is an incorrect statement because it does not show diagonal relationship with lithium. It shows diagonal relationship with aluminium. So this statement is incorrect, and that's why it's the correct answer for this question. After which